नमस्कार and welcome to this session of rotational dynamics. आज हम करने वाले हैं एक question based on moment of inertia. So let's see what the question is. 7 identical discs are arranged in a hexagonal planar pattern so as to touch each neighbor as shown. Each disc has a mass m and the radius r. What is the moment of inertia of the system about an axis passing through the center of the central disk and normal to the plane of all the disks? So here we are having 7 disks, the one in the center and 6 touching each other around that central disk. We want to find moment of inertia of this system about an axis which is passing through C, the center of the central disk, and perpendicular to the plane of all these disks. How to approach this question? For this question, let us see first each individual disk. Let me concentrate first on the disk number 1 with center C1. We will first find out the moment of inertia of this disk about C1 and perpendicular to the plane of the disk. What is the moment of inertia of an axis through its center C1 and perpendicular to its plane? It is mr square by 2. We all know that. So, for the first disk, this number 1, the moment of inertia about C1 is mr square by 2. And then what will be the moment of inertia of that disk about C? So, for that what we need to do is we want to understand that this axis and this axis, they are parallel to each other. So, we will be applying the parallel axis theorem. So, what is it? Moment of inertia of this disk about C is I parallel equal to ICM plus mh square. ICM is the moment of inertia of that disk about its own center of mass, isn't it? And what is m? M is mass of the disk and h happens to be the perpendicular distance between the two parallel axes. Now let us substitute one by one in this formula. So this is equal to ICM, which we have already written here, mr square by 2 plus mass of that one disk is m as given here, mass m, and radius of the disk is r. So the distance between the two axes becomes 2r. This 1r and this 2r. So h is equal to 2r, and then let me have a square of that 2r. So what will be the moment of inertia of a parallel axis through the center C? For that disk number 1, it becomes mr square by 2 plus 4 mr square. You can easily calculate, and then we can get the addition to be equal to 9 by 2 mr square. So this, friends, is the moment of inertia of the peripheral disk about the center C of the central disk, isn't it? How many such peripheral disks are there? Well, we have 6 such disks, and therefore for each of them the moment of inertia will be 9 by 2 mr square about the axis through C and perpendicular to the plane. Therefore, my moment of inertia of the 6 peripheral disks about C is 6 times 9 by 2 mr square. That is equal to 27 mr square. Very easy to calculate. Let this be our equation number 1. And now we are not done because we have left out the central disk. So what is the moment of inertia of the central disk about its own center of mass C? That is going to be mr square by 2. And so the total moment of inertia of all the disks together, that is moment of inertia of the system about an axis which is perpendicular to the plane of the system and passing through C, will be equal to this plus this, that is mr square by 2 plus 27 mr square. A very easy calculation gives me I equal to 55 by 2 mr square, and that is the answer for this question. Well, we can be asked some more variations of this question as well. For example, we can be asked to find the moment of inertia of this system about an axis passing through C1 and perpendicular to the plane instead of C. What will we do then? Well, the answer is we will have to find out the moment inertia about C anyway. Why? Because C happens to be the center of mass of the entire system. And then apply the parallel axis theorem. So that for the axis through C1, we have the formula for moment of inertia about center of mass, which we already calculated, and this happens to be the distance between the two parallel axes once more. So let's calculate moment of inertia about C1. So to find out moment of inertia about C1, we will once again write that same equation, ICM plus mh square. However, the values for all these will be different in this case. What will be the value of ICM? Well, this is the value for ICM here. What will be the value of m? M is the mass of the system. How much is the mass of the system? Well, it is not m, but because there are 7 disks, the mass of the system becomes 7m, and that is the catch point here. You should do it correct. So mass is 7m, and what is h? Well, h is once again 2r as we did earlier. So my answer here will be, first I will write ICM, which is 55 by 2 mr square plus m, which is 7m, into h, which is 2r. So into 2r whole square. And that gives me how much? This remains 55 by 2 mr square, and this becomes 7 into 4, that is 28 mr square plus 28 mr square equal to, a simple calculation, find LCM first, multiply by 2 here, 28 into 2 gives me 56 plus 55, so that gives me 111 by 2 mr square, and therefore the moment of inertia of the entire system about C1, if asked, becomes 111 by 2 mr square, and that will be your answer. Similarly, there can be one more variation, like they can ask about this axis, which is intersection of these two, the center one and this one. So what we do is we will find that value of h. The only difference will be the value of h here, everything else remains the same. Instead of 2r, we will have the distance as r itself, isn't it? Only r. And we get another answer. Likewise, we can find moment of inertia about any point and parallel to this axis. Understand? So that way we can solve these questions. I'm sure you must have understood all the questions, their answers, and how to approach such questions, which is very important. So that's all, friends. Thanks for watching.